Okay, so for today's lecture, we are looking at March 29th. Um, we are going to kind of be introducing a new topic. We're going to be going over electricity and magnetism. First off, today really is going to be kind of like an introductory type lab. And that does not mean that you can kind of just blow it off and you can't do it because it is still technically going to be considered a lab. There's just a couple things we need to go over first. The first is going to be your types of circuits. And of course, if you have seen a circuit or you've heard of it before, you know it has to deal with electricity. So anytime we are dealing with a circuit, it is going to have a power source of some kind. Power source is generally a battery, or if you have like a windmill or a hand crank, it can use human power to provide an energy for it. You are also going to have a voltage, a current, and it is possible for there to be a certain type of resistance. Um, if you have ever opened up the back of your phone or any other kind of device, sometimes you see these like little resistant pins. Normally they're like tan with like black, red, and white stripes on them. Those are resistors. Um, Whenever we're looking at our different types of circuits, please know that voltage is abbreviated with the letter V, or it is referred to as simply volts or volts. Voltages are also measured in volts. So again, that can be your letter V here. So voltage isn't really too hard to understand. Next up will be your current. Current is identified by the letter I. Don't ask me where they got that one from. All I know is that's the set standard for looking at current. We denote it with the letter I. And if you are labeling these, like how strong a current is, specifically an electric current, we are going to use what is called amperes or amps. And then resistors, or your resistance, is measured in what's called ohms. Now, ohms kind of have this weird upside down looking horseshoe thing. That's the symbol that we denote it as. And you are going to have two different types of circuits. You're going to have a series and parallel. And I know I butchered that word, um, I, I believe. So I do apologize in advance. A series circuit is you're going to have your power source, so kind of like your battery, and it is going to be connected with your wire. And let's make our light bulbs orange. Okay, so this would be an example of a series. All of these lights are working in tandem together. So let's say that the power source is good, all three lights are good, then that means all three lights would light up. Now, the thing with series is if one of these lights doesn't work, whether it be the last one, the middle one, whatever, if one of them does not work, that kind of creates a little opening, which means that your circuit is open, which in turn means that all lights will not work. If you have a parallel parallel, P-A-R-R-A-L-L, you'll still have a power source. Again, let's still make our lights be orange. Parallel is kind of like the same thing in math. You have several lines kind of overlapping each other. Now, parallel works a little bit differently. Again, everything is connected. It's a closed system. That means all of your voltage, all of your current, everything is all connected, so everything should work. But if I have one of these lights that doesn't work, the bulb is dead, if I have a parallel series or a parallel circuit, well, you still have multiple other series here within your parallel, which means that my light here and my light here will still work. So let's say this one is off, but my first one and my last one will still light up. They're still good. Same thing if this one, like if this one doesn't work, then these two lights will still work. So, and that is because a parallel circuit is based on several series. They're based on top of each other. And so what you're going to have here is multiple different ways to, wire up your circuit. Now, this does lead into what's called Ohm's law. Ohm's law is simply going to be a fancy term for a calculation. And it is going to tell you that the current is equal to the voltage divided by your resistance. And so again, I'll write that out a little bit differently. It's, of course, the same thing. So current is equal to voltage divided by resistance. And let's go ahead and use your symbols. So amps. Amps is current. Amps is equal to your voltage over your resistance. So again, resistance is also noted as ohms. So that would be Ohm's law and your two different types of circuits. So let me go ahead and introduce you to your activity. So I'm going to close out of our notes. You will see Intro to Circuit Lab. And you know what? Let's go ahead and pull up the, there we go. That'll work. So you're going to simply kind of follow the instructions. Of course, this is going to be on PHET, P-H-E-T, and you're going to follow the directions. It is encouraging you to remake the circuits below. This circuit is simply made of wires. And so let's go into intro. You'd want to make a circuit of only wires. So match it up here. Oops. So apparently it is a little touchy. Here we go. And let's make sure everything is check marked here in the upper right corner. And you can choose between electrons or the arrows. I do encourage the electrons simply because even if something is not moving, you can still see that they are present. But we've made our circuits out of wires. What do you see? Well, you should see nothing. The electrons aren't moving, nothing's there, so there's nothing really to write down. So I would write down under here for my observations, nothing. I'm not seeing electrons move at all. So I'd go to my next one, it says circuit with battery, and you can see here they have the wires and the battery. So let's go ahead and recreate that. And let's see, we may have to cut this, cut that, and let's try that again. All right, so this time you can definitely see electrons are moving, and actually the battery looks like it's on fire. So we can go ahead and we can go back. We can type up. It looks like the battery's on fire. The electrons are moving crazy. So, all right, there's a third one. Circuit with battery and eraser. So as you'll see here in the left-hand corner, I don't see an eraser right off the bat. So what I'm going to have to do is I'm going to have to go through and find it. Oh, here's an eraser. I'm going to cut this, put the eraser on one end. And here we go. And what do you see happening? Nothing. The electrons are staying still. Everything's connected, but nothing is moving. And so again, that's an observation. You would write it down. And then you would kind of have to go through and why? Why do you think it's happening? Why do you think it's not? And again, if they are asking you for your opinion, there's no right or wrong answer. You are simply looking for your opinion. Now, opinions can change as you are educated in the events. So don't feel bad about making the wrong assumption. That is part of the learning process. But again, read the questions carefully, look at what they're asking you to do, look at the pictures and screenshots. Some of these will probably ask for you to give a picture. If they need a picture, simply take a screenshot and insert it. Or you can actually try to hand draw it with Kami. Again, I wouldn't recommend that. That's kind of really rough. But if that's your only option, then that's our option that we need to go with. But if there are any questions, please let me know. I'll be more than happy to help you out. Um, Here we are in part 3. They're just asking you to calculate the current. Again, remember, current is voltage over resistance. And yes, you're going to need to add it up all together. So your total voltage in both of these pictures is going to be 18. In A, your resistance is going to be a total of 20 ohms. And in picture B, your resistance is going to be a total of 10 ohms. So again, you're going over series versus parallel. Any questions in regards to it? That's really about it. So if there were any other questions, please make sure to ask. I'm here the entire time on Google Class or in your GoGuardian. So make sure you have a wonderful day. I'm not going to be here on Thursday. I will have an Edpuzzle video posted for Thursday, maybe with a small worksheet. But that's about it. So have a wonderful day.